No, it's on. It's on. Yeah, I can see the camera.
What is this, bourbon and coke? Or... Is this bourbon and coke? Yeah, no, it's tea. And the tea is actually separating out from the water. Carol, could you hand me my laptop? It's under a white bag here. Carol.
We'll start the presentation momentarily. In the meantime, let's give a big hand to the servers who did such a fabulous job. The other people we need to give a big shout out to is the convention committee. What a fabulous job they did. From my vantage point, everything went extremely smoothly, so that's always the goal. Thanks so much. There's someone at our table, his name is Dave, I think. Dave Acker. Anyone ever heard of him? I guess we better get him up here, and he's going to talk about galaxies. I don't think we need to do a long-term introduction. Everybody knows Dave. Come on down.
Gotcha. Yeah. Awesome. Thank you, Carol. Can everyone hear me okay? Yes? In the back? Yeah? Awesome. Well, thank you. It's a real joy and an honor for me to be here with you, and bless you. Thank you for inviting me. The first meeting that I ever went to, back in the Roman era when I was young, I actually was 15 years old at one point, and the first astronomical meeting that I ever went to was a thing called the Apollo Rendezvous in Dayton, Ohio, and the League had a big presence there, and so I was imprinted with the importance of the League very early on, and it's been there all the time, and of course it's a great cause, and very happy to be associated and a member and do whatever we can to make this great organization move forward. So tonight I would like to talk a little bit about a favorite subject. Again, back when I was young, there was a wonderful book that I got hold of that I was very happy to have that was called Galaxies by Tim Ferriss. Some of you might remember that book. And it was a great book. It was a big, large format book with all sorts of, cool 3D diagrams in space of where galaxies were and what the structures in the Milky Way and the clusters and superclusters. And that really lit my imagination. And so I thought, well, someday, I'd really love to write a book about galaxies. And someday kind of finally came for me in 2018. Fortunately, as you guys know, we're truly, really in a golden age of astronomy. The rate of discovery and understanding about the big questions about the universe, origin, size, age, fate, evolution, etc. of the universe has never been, we've never seen anything like that which we have now before. I think the last generation and a half, we've seen an accumulation of knowledge that has equaled in some ways a couple of previous centuries beforehand. So a couple of years ago now, Random House published my book on galaxies, and not advertising it here, but I'll give you a very short kind of summary of what I wrote about in the book, because in the last 40 years since Tim's book came out, we really have a new understanding of how galaxies form and how they work that's really revolutionary, and particularly in the last 10 to 15 years. So I'd like to talk about that a little bit tonight. There we go. Well, this revolution really began in earnest with galaxies 100 years ago, now this year. What year is this now? 2023, yeah, okay, I'm old now. But it was 100 years ago now, in October of 1923, that a fairly brash astronomer in Pasadena, Edwin Hubble, liked to journey his way up to the 100-inch Hooker telescope on Mount Wilson in Pasadena. And he was a little bit of a difficult guy to get along with. He wasn't the most popular guy with his colleagues. But he was very interested in studying what were then known as spiral nebulae. And so he would like to take spectra and other data of such spirals. And on October 4th, specifically of 1923, he took one of the most famous images in the history of science. This image here, and you probably know the story, so I won't belabor it, but he was incredibly excited. You can see near the top, he put tick marks around a fairly faint star and wrote N for nova, and he thought he was very excited because he thought he had discovered a nova in this spiral nebula, as they were then known, of course. He took the plate down and analyzed it for a couple of days in his office in Pasadena, looked at some earlier plates, and practically fell out of his chair because as members of the AAVSO, who I think are still here now, know as well or better than anyone, he recognized a pattern of brightness in previous images and found that this was not a nova. It was a Cepheid, so-called Cepheid variable, named for Delta Cephei, the prototype. And this type of variable star, as you may very well know, has a very distinct pattern of brightening and faintening, and is absolutely calibrated in terms of precision. And so its apparent brightness can be used as a measure of distance. So Hubble was shocked by this, and he estimated the distance to the Andromeda Nebula at 1 million light years. Now this at the time in 1923 was 3 times the diameter of the imagined size of the universe. So something crazy was going on here. Now, of course, we know that it's 2.5 million light years away, and his estimate was an underestimate. But at the time, it was a very different world. Los Angeles was very different. There were about 1 million people in the city there. Robert Millikan had just won the Nobel Prize at Caltech across town for studying the charge carried by an electron. Across town, Amelia Earhart was taking flying lessons, and a young cartoonist called Walt Disney arrived in town that fall with, what was it? It was $40 in his pocket, and that turned out okay. Except for, maybe buying property in Florida, but that's another story. So anyway, it was a primitive time, and a revolution in science was happening then in the Los Angeles area, chiefly carried on at Mount Wilson. Well, realizing what he had found in a single observation, Hubble had essentially reset the distance scale of the universe and also the nature of the universe, because he discovered the nature of galaxies, these so-called spiral nebulae that were discussed and analyzed since the time of Lord Rosse in Ireland in the 1840s and beforehand. And now it was understood that these are large systems of stars, gas, and dust. Research by Hubble and by others even earlier than Hubble, as early as 1912 at Lowell Observatory, which is near and dear to some of our hearts, by V.M. Slipher with his spectroscope, their spectrograph there, found that these objects were moving away from each other, and therefore running the cosmic clock backwards, he derived the first inference of the Big Bang, of the origin of the universe. Now, of course, we know through, I'm sorry if you like, a lot of astronomy enthusiasts are still kind of skeptical about the Big Bang, but our pals Arno Penzias and Bob Wilson in 1964 confirmed the Big Bang with the cosmic microwave background radiation, and a slew of cosmological satellites since then, most recently the Planck satellite, have confirmed that the Big Bang happened, and it happened 13.8 billion years ago. So this was really a revolution of understanding how we got here and how the universe has evolved in its crudest sense over time. Well, what are galaxies all about? As with any science, whether it be understanding mineral specimens or seashells or bones of animals or galaxies, the first major steps that have to be done occur in classification. So Hubble wrote a famous book in 1936 called The Realm of the Nebulae. You may have a copy or be familiar with it, and he categorized galaxies in that time in a simple way with spiral galaxies, barred spiral galaxies, and irregular galaxies. And subsequently, after Hubble's prime and up until the late 1950s, the French astronomer who I was privileged to get to know late in his life, Gerard de Vaucouleurs, who came over to the University of Texas, really extravagantly expanded the organization of how to classify galaxies. And now we still use the de Vaucouleurs system. And all kinds of things like bars and the structure internally within galaxy arms, how tightly wound they are, and the density of stars, character of nuclei, and so on is all based on the de Vaucouleurs system. Well, by the mid-20th century, astronomers realized that galaxies are the basic building blocks of bright matter in the universe. Stars, gas, dust, and other critters make them up, and we know that we're in one. And for many decades, we thought it was an ordinary spiral galaxy, like our neighbor, the Andromeda Nebula, which became the Andromeda Galaxy, and we'll get to some revisions of that shortly. We have thought for many years that the number of galaxies in the universe is approximately 100 billion galaxies. There was a study, however, in 2016 by our pal Chris Consolis in the United Kingdom that estimated the number of galaxies, you may remember, at about 2 trillion. But of course, this is probably the best room to ask this question in the United States of America right now. What do telescopes do for us? Well, they're time machines, right? So as we look at more distant objects, we're looking back in time. So very distant objects that came together to make fewer larger objects. In the early universe, there were a couple of trillion galaxies that we know of around, and in the current cosmic time, if you will, there are about 100 billion in our sky. And we'll get to this later, but the visible universe may not be the whole thing, of course, some of you know that too. So where do we start understanding galaxies? Well, with the Milky Way, our own galaxy. Of course, if the rare situation exists that we have a really dark sky and we can get outside of light pollution, outside of cities into a nice dark sky and it's clear, we can see, of course, the Milky Way cutting through the evening sky in the winter and summer, and these great star-forming regions in it, and we can actually see a lot of the dust in our galaxy as well, seeing the plane of the galaxy, the light that's partially resolved and largely unresolved from several hundred billion stars as seen from within. You might know that if we look towards Sagittarius and primarily in a more precise way, between the open cluster M6, is it up? Maybe, no, it's not on this, okay. Almost on our chart here, but if we look between the open cluster M6 and the Lagoon Nebula and draw a line between those two very prominent deep sky objects and move just a short distance off to the right, that's the direction of the center of the Milky Way. However, galaxies contain, among other things, lots and lots of dust, and so visibly, with visible light with our eyes, if I'm not going to knock this over, we're seeing only about a quarter of the way to the center of our galaxy. We know that the Milky Way consists of something on the order of about 400 billion stars. We don't know exactly because faint stars, M dwarfs, red dwarfs, are faint. So they're hard to see over long distances, and we can only estimate the most numerous stars, those dwarfs, and how many there might be. Excuse me. Okay, now I'm less likely to spill that. Okay, for decades, Hubble and DeValcalure and everyone thought that the Milky Way was an ordinary spiral galaxy, like the Andromeda Galaxy. However, there's a study, and I'll give a plug because this is a rare opportunity from where I come from, but there's an astronomer at the University of Wisconsin-Whitewater, a branch campus, small campus in the middle of nowhere in Wisconsin, if you'll permit the term, Bob Benjamin, and he led a study with the GLIMPSE instrument on the Spitzer Space Telescope, and in the year 2015 mapped the spiral arms to a very high precision for the first time of the Milky Way, and we found out that indeed we live in a bird spiral galaxy. So that's where we are. We're about 26,000 light years out from the center of the Milky Way, and it's good that we're out in the suburbs, if you will, the boondocks. It's a nice, safe, calm place to be. Let's see, I got ahead of myself here. I don't know if I bumped that, forgive me there. But looking toward the constellation Sagittarius, as I said, is more or less toward the center of the galaxy. This is an infrared image of the center of the galaxy here. It's a really good thing that we're out from the center because there are all sorts of dangers in the centers of galaxies. We now know, and have for quite some time now, that there's a supermassive black hole in the center of the Milky Way. It has the mass of about 4.3 million times that of the sun. And there are things like antimatter and all sorts of other hazardous problems in the centers of galaxies and close to those violent regions with a lot of star formation and churning of things going on. So it's a good thing to be out in the calm countryside, if you will, of the galaxy. Well, this is a modern shot, Tony Hallis's, one of Tony Hallis's recent shots, relatively recent shots of the Andromeda Galaxy, our big galactic neighbor, if you will. And of course, galaxies, like people, like to hang out in groups. And we know from the time of Hubble discovering and studying groups of galaxies and onward and up to recent times here, Alan Sandage and Jeff Burbidge and others, that there are at least 55 galaxies in our so-called local group of galaxies. Hubble named, really inventively, our own group, the local group, which was a pretty good name. There may be as many as 100 members of the local group. Just like stars, the most abundant galaxies are dwarfs. And we'll get to this a little bit later, but what do galaxies like to do over time? Well, despite the fact that the universe is expanding, we have universal expansion that's going on all the time. And we know even now, I'll jump ahead again, that dark energy means that the expansion is accelerating over time. That discovery came in 1998. But on small scales, gravity is hard at work. And so if you look at, for example, the Hubble Deep Field, or even most recently, a few months ago, the first Webb Deep Field, you can see all sorts of faint blue objects that are primitive proto-galaxies. And the story of galaxy evolution that was debated for a long, long, long time is that over time, those proto-galaxies come together and they merge and they make fewer, larger galaxies. So what do galaxies do over time? They eat each other, and they merge and they get together. The primary members of our local group, of course, are the Andromeda Galaxy, the Milky Way, and then M33, the Triangulum Galaxy or Pinwheel Galaxy that is much smaller than the other two. The Milky Way, of course, is smaller than the Andromeda Galaxy, which is the largest object in the local group and has a retinue of almost a couple of dozen satellites. And of course, you can see two of them here. M32, just above and left of the center of the Andromeda Galaxy, which is tilted with the near axis toward us below the nucleus, and NGC 205, which is the fainter, larger elliptical galaxy, dwarf elliptical. And you can see Tony has captured very nicely the tidal action, the pull on this little galaxy. You can see the distorted halo of material around the galaxy. And eventually, as the Milky Way has done with lots of our small neighbors, the Andromeda Galaxy will consume these galaxies into its own disk. So, the Triangulum Galaxy, as you might know, on a night like we had last night that's a little bit difficult because of a reasonably bright moon, has a low surface brightness, and it's about 3 million light years away, so it's a little more distant than the Andromeda Galaxy. It's a little bit odd, because it has some gigantic star-forming regions in it. The one that's above and just to the right a little bit of the nucleus of the galaxy here is so large, it's one of the largest star-forming regions known in the universe, one of the two largest. It has its own NGC number, and it's NGC 604. Also, M33 is an anomaly because most large galaxies, not dwarfs, but most large galaxies have central massive black holes. This is a discovery that came along by the 1990s with astronomers using the Hubble Space Telescope and finding lots of supermassive black holes in the centers of galaxies. M33, however, has no supermassive black hole, and nobody quite knows why yet. Well, as observers know, funny things can happen in space, and there are lots of galaxy mergers, as I mentioned, happening because of gravity overcoming the expansion force on local scales. And fortunately for astronomy enthusiasts, we can see lots of examples of merging galaxies in the sky. This is the antennae galaxies in Corvus, NGC 4038, 4039. And it's a really good example, and you can see the tidal interaction of these two very, very long, faint tails. And eventually these two disks of the galaxies that are very distorted will come together and merge into one large and fairly disorganized disk. So the local motions on smaller scales are very important, and even in widely dispersed galaxies, not necessarily even in clusters of galaxies, they can get together and form larger galaxies. Here's another example. This is NGC 2623, which is another nice merging galaxy that is a little bit farther down the road in terms of a merger. It's not a terrible thing that galaxies get together and merge. And in fact, when he's not busy trying to make trouble in the international press, another of our friends, Avi Loeb, who has been recently the chairman of the astronomy department at Harvard, has written a paper about a dozen years ago or so with some collaborators demonstrating that about 5 to 6 billion years from now, the Milky Way and Andromeda will actually merge. Again, most galaxies are moving away from each other. That goes all the way back to Slipher in 1912. But the Andromeda galaxy is moving toward us at 300 kilometers per second. And so we're not going to be witness to it, I'm afraid. But eventually it will merge with the Milky Way, and we will have the super galaxy that Avi and his team very creatively labeled Milkomeda. Well, as we move farther out into space, the diameter of our own local group of galaxies is about 10 million light years across, hop, skip, and a jump in universal terms. But if we go about 54.5 million light years away, we get to the center of the largest group of galaxies in our part of the universe, the Virgo cluster of galaxies, which has about 1,300 galaxies of all different types, so-called morphological types. And of course, it's centered well in the evening sky, typically in the spring, so that in April and May, it's really galaxy hunting season, and we have great opportunities to see them. Some of the most interesting galaxies in the nearby universe are in the Virgo cluster. One of them that's a real poster child is the giant elliptical galaxy M87. And I don't know if you can, whoops, whoa, there we go. Nope. Oh dear. I think the paper is actually leaning on buttons here. Sorry about that. So we're back to M87. I don't know if you can see because of the searchlights that are on here near the screen. It's a Scott Roberts joke, but it's okay. But I don't know if you can see, oh, there he is. Okay, sorry, Scott. But if you can see just very close into the nucleus of this galaxy, that's an enormous galaxy, and just to the right and above the nucleus, can you see a tiny little jet of material there very close into the center of this galaxy? Well, this is an amateur shot of M87 showing the jet of material that falls into the central black hole in this galaxy, part of which does not go into the event horizon of the black hole and is hyper-accelerated out into jets that escape the pull of the black hole. That's quite astonishing that you can see this. And the M87 black hole makes the Milky Ways look kind of insignificant, because although the galaxy here is about 120,000 light years across, the Milky Way's disk is about 100,000. But M87 is a sphere. The Milky Way and disk galaxies are very, very thin, about 3,000 to 4,000 light years thick. So the volume of stars here is vastly larger. And the mass of this black hole is about 3.5 billion solar masses. This is a galaxy that's a little larger than ours, end to end, and has a central black hole with about 1,000 times more mass than our own galaxies. So it's quite a place to be involved with. And as well, for the observers, you may know this, but you can see a bunch of fuzzy stars around here. The Milky Way, our own galaxy, has a collection of about 200 globular clusters. These globes, we saw one last night, I think many of us did M13 in the telescope upstairs in the observatory. These are globes of old stars, aged stars, that actually came together and formed before the disks of most of these galaxies coalesced. So for example, the Milky Way's disk originated, it's believed, about 9 billion years ago, but the stars in the globular clusters orbiting our galaxy are older yet. And so it's quite amazing that M87 has not 200 globular clusters, but something on the order of 12,000 globulars, M87. It dwarfs in scale the Milky Way in several respects. Then, just as astronomers thought they were starting to figure out what galaxies were in the story and how they form and evolve and so on, the rug got pulled out from them again in the 1970s, well, starting in the 1960s, with Martin Schmidt at Caltech, and then largely with lots of other people in the 1970s. And for about 25 or 30 years until the 1990s, the mass confusion reigned, because the story of quasars, quasi-stellar objects that were very, very distant, the distance measurement to them, but were pinpoint bright objects, came about. And there were all sorts of other crazy things in the astrophysical zoo that seemed to be high energy, very distant objects. Seyfert galaxies with active nuclei, BL Lacertae objects that were like this, believed to be a variable star, turned out to be a remote, very energetic galaxy. And suddenly in the 1990s, again with Hubble, it became clear that these were all, not 20 different things, but the same phenomenon seen from different geometries. So what we're seeing very distantly in galaxies are the centers of them, so-called quasars, that are active black holes, and there's a lot of material falling into the black holes, and therefore generating a lot of energy that escapes the event horizon. And what happens over time, to make a long story a little shorter, is that galaxies with black holes, most galaxies, in their centers clear out a lot of material, and the black holes go from very, very active in the early universe to quiescent, and they sort of go into a sleep mode much later on, unless fun things happen like galaxy mergers, dumping lots of gas and stars back into them, which reawakens the black hole into a crazy cosmic flu. So that story took a long, long, long time to figure out. This is an so-called Einstein cross here, which is a distant quasar directly behind the nucleus of a normal galaxy that's much closer. And never bet against Albert Einstein, please, because every time he's right. And he predicted this in general relativity, that this would create a cosmic lensing, and that's what we're seeing, the 4 images of the distant quasar around the closer galaxy. Well, I didn't update this for Webb a few months ago, but this is the original so-called Hubble Ultra Deep Field. And you may ask, well, you have a lot of time on your hands, astronomers. How do you know that there are 100 billion galaxies in the universe? Because the ultra deep field, which was taken in a very deep southern part of the sky, it's a tiny, tiny piece of the sky, smaller than a thumbnail. And the galaxies in this image, there are a few foreground stars in the Milky Way in this image, but there are 10,000 galaxies, and you can see these little proto-galaxies, many of which are bluish in this image, 10,000 in this tiny little piece of the sky. And simply extrapolating that over the entire sky gives us approximately 100 billion galaxies. So we live in a very, very large universe filled with lots and lots of galaxies beyond our own. This is getting back to the quasars again here. This is a famous poster child quasar that Schmidt and others studied, that is 3C273. This object and 3C48 were the original 2 well-studied quasars when everyone wondered what was going on with these high-energy objects. Some objects in the sky you can just look at in recent modern observatory images and see the chaos that's happening in some high-energy galaxies. You might have observed this. This is Perseus A, otherwise known as NGC 1275, and it's a high-energy radio source, giving it its name Perseus A, and just look at the chaos that's going on here. This is another very massive, central supermassive black hole, and it's a galaxy merger that's going on, and which has created new eras of starburst formation. And I mean, just look at this, it's chaos. And so we know that when galaxies get together, and especially big ones, things flare up again, and this may actually happen with us again with Milkomeda in the future. Most galaxies sort of exist in a gentle and balanced state. They're sort of balancing against internal and external upheaval sources. But there are lots and lots. We talk about sometimes, single galaxy. We think of the Milky Way being alone, even though we're in a group of galaxies. The Andromeda galaxy, it's a neighbor. There are big, rich clusters of galaxies, many of the Abell clusters, as well as moderate-sized clusters like Virgo. But many, many, many galaxies exist in small groups throughout the universe, like this one. And so again, there's sort of a balancing act here of remaining separate and relatively balanced and organized, and falling in by gravity and having new episodes of chaos take place. Well, we don't know, and we'll be long, long gone, I'm afraid, by this point. But something, as I mentioned, like 5 to 6 billion years from now, the Milky Way and Andromeda will get together and merge. If you've ever been in the southern hemisphere, or even looking at it fairly low down at a latitude like this, you know that Centaurus A is a really great and very cool and weird galaxy, and pretty bright too, with a high surface brightness. And here we can see, again, it doesn't take a lot of imagination to know what has happened here from the astrophysical data. This is a massive merger of disk galaxies. And for a long time, The pioneers of galaxy evolution had no idea. Well, you know, galaxies form as disks, and you have angular momentum that increases, and that makes sense. And just like solar systems form, we believe, you know, material disks around stars. Well, how do you get elliptical galaxies? You know, this was a puzzle for a long, long time, and it turns out that elliptical galaxies form from mergers. So it may be, you know, we have this huge dust band and a new era of star formation out in front of the dust band that you can actually see in a large Dobsonian as an amateur. You know, it's amazing that as astronomers, as astronomy enthusiasts, we have the same laboratory that professional astronomers have, which is unique among the sciences. But here, we may end up with something like this eventually, long after we're gone on planet Earth. So, just to make things even more complicated, many of you have heard of cosmic inflation, which in 1974, two different groups posed to the world, one led by Alan Guth in the United States and another by Andre Linde. And it turns out that, you know, we don't know the full story, but most all cosmologists believe pretty strongly in cosmic inflation because that early era of hyperinflation from about the size of a pea to a grapefruit immediately after the Big Bang fractionally explains a lot of things that we see observationally later. We don't have time to go into all of that right now, but trust me, it's true. So probably cosmic inflation happened, and one of the after effects of that would mean that the visible universe that we see is not the whole universe. And you can sit down and listen to someone like Alex Filippenko describe this, and it sounds like, you know, the worst science fiction movie you've ever heard of, you know, that maybe the universe could be infinite, but it's mathematically quite plausible. So let's take a friend like the Whirlpool galaxy, which is a normal spiral, face-on, very nice spiral. I think we almost looked at it, or maybe some of us did last night. And this little interloper, NGC 5195, zipping past us here on the lower left, to the left of the galaxy. And this is really a nice stately portrait of a spiral galaxy and the spiral structure. However, galaxies are not well ordered, and we know that they're chaotic, and we know that the distance scale, if I can just ask for your attention for a couple more minutes, I'd like to talk about a couple of things that we all kind of fall into as science enthusiasts because we want to believe, you know, but science fiction and science actually have a very clean line between them. And we can't believe in science part of the time, but not when, you know, the few times that it's no fun, you know. But let's imagine, just to understand the distance scale, which Hubble began to unlock for us, the distance between the sun and Earth as 1 centimeter. So that's about that much distance between thumb and forefinger. We've traveled physically as human beings an almost infinitesimally small, tiny fraction of that distance. Okay, and the planets are strung out a few centimeters in diameter to the closest ones, all the way out. Does anyone still count Pluto as a planet? Wherever Clyde is, he's smiling right now. Thank you, okay. That's 40 AU out, so that's 40 times that distance out to the average orbital distance of Pluto. So the inner edge, physically, of our solar system, the inner edge of the Oort cloud, the shell of comets of maybe a couple of trillion cometary nuclei, inner edge of that is 10 football, I'll say 10 Lambeau Fields, being in Wisconsin. Sorry, Dan. 10 football fields to the right there on that scale would be the inner edge of the Oort cloud. The nearest star to us, one of those young dwarfs, Proxima Centauri, is 4 times more distant yet. So one of the harsh realities as the United States Congress spends its valuable intellectual time investigating UFO landings, among other things, is that, photons, which are now striking our eyes, all of us, can travel at the speed of light, 186,000 miles per second, because they're massless. But things with mass take a huge amount of energy to move at appreciable, very tiny velocities even. So the most realistic idea you could have to move something with any mass at all, a portion of one of our legs, to get to Proxima Centauri would take something on the order of 100,000 years. So it's unlikely, given the energy required and the understanding that we have of the conservation of energy and mass and living beings, that there are going to be aliens who land in Central Park and take us out to dinner at 21, with a nice dessert and a couple of drinks. As Seth Shostak, our pal, likes to talk about, the universe could be filled with life. Because let's go back to the numbers just for a second. There are, say, on average, 100 billion, maybe 200 billion stars in a galaxy. There are at least 100 billion galaxies in the universe, and maybe a whole lot more. So let's say very conservatively that there are 10,000 billion stars in the universe, just for a moment. We know that there are lots of planetary systems, as we would expect, around us in the galaxy. Exoplanets, there are 5,000 and change known now, and lots and lots and lots of them waiting to be confirmed. And observatories up there doing it, still TESS and others. We know through spectroscopy, which was developed in 1862, originally as a technique, that chemistry is uniform everywhere in the universe. We know that organic chemistry, that's fairly complex stuff, is commonplace throughout our solar system, and we believe elsewhere. The first cometary sample that was returned to Earth by the Stardust mission in 2006 contained the amino acid glycine, the simplest amino acid. So it's not a huge wager, given that many stars and planetary systems and the uniformity of chemistry, that there, as Carl Sagan used to like to say, is life spread abundantly all through the universe. But the distance scale means it's exceptionally unlikely, well nigh practically maybe impossible, that we'll ever shake hands with advanced aliens. So if you want to be even more depressed, although SETI, just to be fair to Seth and Jill, SETI is very real. We may be able to detect civilizations, of course, from afar. That's very, possible, although the directional signals have to be, just right. So we may be in a universe that's filled with life, even sophisticated life, but running into them on the turning around the corner of the block at 52nd and 6th Avenue is going to be difficult at best, regardless of the increase in sophistication of technology. To make you even more depressed that you come to my lecture, I'm going to tell you that the sun is a variable star, okay, and it's slowly increasing its so-called bolometric magnitude, its energy output over time. And about 1 billion years or so from now, and a lot of scientists have produced papers about this, the sun will increase its energy output to I'm not talking about global warming and the stuff that we're doing, which is pretty simple carbon dioxide production, but I mean the sun's real energy output 1 billion years or less from now will boil the oceans off of Earth. That's going to kind of ruin our weekend at that point, okay? So life on Earth will be done about 1 billion years from now. The most primitive life on Earth, that's from places in Canada and Western Australia, the simplest precellular life goes back to nearly 4 billion years, 3.9 billion years. So the majority of life on Earth, fabulous living beings, has already happened. The story of life on Earth. But to be a little more optimistic, it's an amazing thing to be here with you tonight. Thank you for allowing me to come by and cheer you up with this information. And the fact that we're made out of the same, not just the same type, but the same atoms that were produced in the early universe, hydrogen, helium, and deuterium. And then a lot of heavier atoms, as astronomers would call them, from the deaths of low mass and high mass stars and the mergers of neutron stars, which gives us gold, silver, and platinum and other cool stuff to wear. that we're made of the stuff of the universe, literally the same atoms that were recycled into our bodies, and we can sit here and be sentient and talk to each other and talk about this stuff and think about it and debate it as science rolls on, and we get a slowly, very slowly refined picture of what's going on in the universe is practically a miracle. So thank you for having me tonight. If there's any time left, I could certainly entertain questions, but I know we have awards as well to get to. So thank you very much.
Dave, it's always great to have you at our meetings, and as a special token of our thanks, I would like to present you with the Astronomical League Presidential Citation Award. So, to start out our awards tonight, I'd like to present Vice President Chuck Allen.
We take a break for about 5 minutes. Sure. That works. 5 minute break. Dave. This is our lighthouse.
You want it gone?
Okay, that worked. Okay. No problem.
Confused.
Sorry. I don't think you need that. This is just that was an HP. No, that wasn't. Let's see if this is working. Yeah, the joke is that. I will.
Guys, I think we can take these steps. I don't think they're put down those changes. We can probably pick the steps up and move them to the other side. Let me see if I want to see if I can do that without actually. Or we can probably even put it on the
So in order to do that, we have to do it. And that has to be connected to Zoom.
We can. Does it have to be through that? Do you have an HDMI out that we can put through your computer to crank out, or is that? I mean, we can. It's just an HDMI popping out whatever. Okay. Yeah. That was a grand idea. That could have been
But it can be done.
There's no way they can hear her either.
Chuck, if you can jump on Zoom, with this, then you can share your screen.
I want to say there was a way to put the audio out.
You know, like the way you do it
anyway.
anyway. Right? So why don't you do that?
I've never done it.
Y'all certainly one time in Zoom, I think y'all. And is the closest thing I can.
Is this your computer?
Yeah.
Yeah. Okay.
That's how it works.
Yeah, we
I didn't set up a meeting.
Okay. And then go join the meeting that I gave you the credentials for.
You get it to me in text though.
Yep, and then we don't even need to have a secret I was, yeah, I talked about it. Meeting on the you know.
Christina, can you hear me?
Okay. Christina, can you hear me?
Yes, I can.
Okay, fantastic. We're going to start our youth awards first tonight, and the first one we're going to do, we have live streamed here, as you can see, through Zoom. I'd like you to meet Christina Ding, who's the winner of the 2023 Horkheimer Smith Award for Service. She's a member of the Texas Astronomical Society of Dallas. We have some representatives from that club here. She spent quite a period of time from 2018 to 2021 providing weekly lessons in astronomy, in math, and in English to elementary school students from low-income areas in China. She did this using very popular and increasingly popular PowerPoint programs that had a very significant impact on those areas. She is also an international astronomy and astrophysics competition ambassador and president of her high school physics team. She's a recipient of the International Astronomy and Astrophysics Competition President's Service Bronze Award. She's also secretary of the TASD Teen Section for the Astronomical Society of Dallas. She coordinates the activities of that group and reports those activities to the editor of their newsletter. She has participated in countless outreach events, such as Moon Day, and is engaged in remote control of micro-observatory telescopes, and has taken some outstanding astrophotos along the way. Christina has earned a cash prize of $1,750 and a beautiful plaque that I hope she has already. And Christina, if you're able to, could you tell us just for a couple of minutes a little bit about your work with the students in China?
Yeah. So, hi and thank you, everyone. I'm really excited to receive this award, first of all, because both astronomy and community service are actually a really important aspect of reflection of who I am. And to start with my experience in volunteering in China, it was a really fun and rewarding experience. I started it when I was in middle school, and among all of the teachers and tutors, I was the youngest. And it started out with English, teaching English and math to the children from low-income background in China. And later, me and another girl decided to add the astronomy course to the kids, and we think this is really important because astronomy is a really cool science, and currently we only had math and English, and we both really love astronomy, so we spent a lot of time designing the course and making the PowerPoints and slides and everything. And it started out with like teaching them about like solar systems and the galaxies and stuff, the most basic and easy astronomy concepts, and I ended up showing the kids there how to make a like their own telescopes with the cardboards and lenses, which was what I learned in a summer camp back in 7th grade. I really liked experience of like learning something the people that I can give help to. So yeah, that's a little bit about my volunteering experience in China.
Well, we want to congratulate you. I know you can't see, we have a very, very big audience here filling a banquet hall, and we're certainly glad to meet you. If you don't have that plaque yet, you will very soon, and the check along with it. And we really want to thank you for all the work you do. Congratulations.
Thank you.
Okay, I'm going to disconnect now. Okay. Let me get reorganized here just a second. All right. Okay, now we'll be rolling a little faster. We have two service awards, as you may know. The winner of the Horkheimer Dario Award and a $1,000 prize is somebody you may have met in Albuquerque last year. That was William Gaudemoller. There's a big hit with most of the people who are out there, if you remember him. He is the only person in our youth programs to win 3 major awards. He won the Smith and Parker Awards last year, and this year the Dario Award for Service, and again the $1,000 prize, and also second place in the Horkheimer Parker imaging competition this year. He could not attend, but he's the first student from his high school, Menominee Falls High School, to attend Harvard University, where he will be in just a month or so. And he's with the Milwaukee Astronomical Society. Okay, now. And now we have some award winners who were here today. If you attended this morning's programs, you saw 2 amazing young people who engage in astronomical research at what our judges regarded a professional level. And since Leon went first this morning in the speech, we'll reverse the order tonight. We have 2 winners this year. They tied for first. That's the first time in the 32-year history of the NIA Award, the National Young Astronomer Award. And I can't, again, let time pass in talking about these awards without recognizing Scott Roberts, who, when with me in 1994 and since then with Explore Scientific, has for 3 decades supported this program financially, and we couldn't have done it without it. Thank you, Scott. Where are the steps on that side now? Okay, could Caitlin Wang come forward? Caitlin is a senior at the Harker School in San Jose, California. She was a finalist at the International Science and Engineering Fair in 2023. She has taken a number of college courses and is an active amateur astronomer who's hosted city star parties, eclipse parties, and given programs in optics and cosmology. Her program, if you saw today, was discovery of the smallest ultra-short period planet using a novel GPU parallelized phase folding detection system that resulted in the discovery of 3 ultralight exoplanets, Kepler 1598d, the smallest USP ever discovered, and Kepler 270d being among them. It was a rare USP orbiting a high temperature F-class star. She will receive the first place telescope prize, as will our co-winner, provided by Explore Scientific. You may have seen that telescope in the back room here earlier, and she received a trip to ALCON as well. Congratulations. Okay, our other first place winner in NIA this year, Leon Garcia. You come forward. Leon is a graduate of Corvallis High School in Corvallis, Oregon. He will be attending Stanford University in a little more than 6 weeks. He was an ISEP finalist in 2021, 2022, and 2023. That's the International Science and Engineering Fair. Not in 2020, but that's because there wasn't an ISEP that year. He was also a 2-time finalist and 3rd place winner in the NIA competition when he was in his early years in high school. His project was simulating the dynamics, collisions, and morphology of galactic ultralight dark matter halos, where he simulated the behavior of dark matter halos in collisional galaxies and interstellar gas clouds and during accretion events. And it was designed to improve our understanding of dark matter halos and shaping the distribution of visible baryonic matter in the universe. And he receives the first place telescope prize provided by Explore Scientific as well, and a trip, of course, here to receive his prize. Congratulations. We have two young people who tied for third. Because of the tie for first, it resulted that way. We'll have to figure out a way to avoid that in the future, but here are the two young people who received third place plaques from us for the NIA competition. This is Lucas Liebschitz of New York City. He's a senior now at Columbia Grammar and Preparatory School in New York City. His project was creating super resolution spectra from Titan's equatorial dunes. The other third place winner was Maud Taruno, a sophomore at Upper Darby High School in Upper Darby, Pennsylvania. And his project was identifying lunar lava tubes using thermal inertia mapping, kind of an interesting project where he used existing thermal maps taken during daytime and nighttime of the moon and subtracted the nighttime images and was able to detect existing lava tubes. So now it's a way of finding new ones. Very clever project. Okay, I'd like you to welcome to the stage the winner of this year's Horkheimer Parker Imaging Award. The winner is Dhruva Kalyani of the Milwaukee Astronomical Society. He is a young man coming to the stage now. He's a senior at New Berlin High School and worked with William Gadamoller on imaging, obviously very successfully. Here's his image of the Jellyfish Nebula, and he will be receiving a check for $1,000 for his work. This young lady is Avni Dar Galkar. She's 12 years old and was adjudged the winner of the Horkheimer O'Meara Journalism Award this year. She's currently an 8th grader at the Charles F. Patton Middle School in Kennett Square, Pennsylvania, and a member of the Chester County Astronomical Society. And her essay, The First Space Tourist, which you'll be able to read in the September issue of Reflector, has earned her a $1,000 cash prize and a beautiful plaque as well. This young lady is Therese Bauer of Orinoco, Minnesota. She submitted the runner-up essay in this year's contest. She's a homeschooled 8th grader and a member of the Rochester Astronomical Society, and she wrote an essay entitled Cookies and Cooperation on the International Space Station, which earned her a $500 prize and a beautiful plaque as well. Those of you who have ever looked at anything related to the Kalamazoo Astronomical Society know that their newsletter and their website are simply stunning. And this is the man responsible for that, Richard Bell. He's the longest serving president of the Kalamazoo Astronomical Society and is the winner of this year's Mabel Stearns Newsletter Award for his newsletter Prime Focus, which he has worked on for a mere 27 years. The winner of the Webmaster Award this year is Bernard Argier of the Astronomy Club of Asheville in North Carolina. He's a past president of the club and has served as its webmaster for several decades. Visibly stunning website that he has maintained, and congratulations to him on winning this award. Beautiful. We have, of course, the Williamina Fleming Imaging Awards that we've been awarding with the support, again, of Scott Roberts and Explore Scientific, for which we thank him greatly. And the winner this year of the Deep Sky Imaging Award in the Williamina Fleming Imaging Awards is Anne Shaftour. You see her here, and this was her winning image, one of the winning images, the horse helmet. And she will receive a very large plaque. Hopefully she already has it. And congratulations to her. The second place award in Deep Sky went to Suzanne Mears. These are both members of the Colorado Springs Astronomical Society, I should emphasize. So there's a little internal competition in the imaging category here, and all healthy, I'm sure. And she has done some beautiful work, I think you would agree, that image of the horse head. And I'm sorry they couldn't join us, but congratulations to your club. Fantastic job, obviously, and congratulations to both of these ladies. The sketching award this year goes to John Schwartz. He's a league member at large from Simi Valley, California, and he won for a very detailed sketch of M42 seen here. He does just really fantastic work. I hope you will read the article in the Reflector about the manner in which he makes these drawings. It's just absolutely incredible. Okay.
We have a new sponsor.
A new sponsor, which is
Sketching award this year, which is
telescopetrader.com is our new sponsor for this award, and we thank them. We are looking for sponsors for some of these awards, by the way. So if you know of companies that are interested in sponsoring youth awards or our general awards, we'd certainly be interested in knowing about that. Okay, we have two more imaging awards, William E. Fleming Imaging Awards, to give out tonight. And we do have a winner in our midst who won two of them. One, a Solar System Award, and the other, the Wide Field Award. And that is our own Terry Mann, Secretary of the Astronomical League and past president.
Make some more room on our wall.
Congratulations, Terry. Yeah. Okay, before I turn this back over to Carol for the general awards of the Astronomical League, will housekeeping be done here? Yeah, you want to pose with both? Okay, last, but before I turn it over to Carol, I'd like to recognize one other person, have him come up here. The young man you see on the stage who's helping us is Kyle Harrington. He's the younger brother of Scott Harrington, who spoke on our panel today, so at least one panel. He spoke also last year at Albuquerque and will speak in Kansas City and again at Bryce Canyon. He is an incredible young astronomer who began doing research on the limits of naked eye and binocular visibility at the age of 14, inspired by Jack Horkheimer, no less. Has published huge compendia of research online since then, which I used in some research I did for a program I happened to give here during the LIGO tour. He's been a very loyal friend and a tremendous observer and young astronomer who is now a regular writer for Sky and Telescope magazine. He and Kyle and his two older brothers who were present in Albuquerque last year and who helped me with the Inverse Scale program live on a family farm in Evening Shade, Arkansas. And now he's a regular writer for S&T, working on his 5th article for them. And so we would like to confer on Scott lifetime membership in the Astronomical League.
The GR Bob Wright Award recognizes people who have performed above and beyond the call of duty. Some of these people have held one or more offices in the Astronomical League. Others held committee chairs. Still others have just done a tremendous job in some aspect of the Astronomical League. Whatever the reason for the award, it recognizes a hardworking member of the Astronomical League. This year's first recipient is an exemplary candidate. He had a dream 4 years ago for his club to host an ALCON convention. This week, that dream has been realized here at ALCON 2023. The 2023 winner of the GR Wright Service Award is Stephen Tilley.
I'd like to thank the club members, because the club members, without adopting my dream, were going nowhere else. I'd like to thank many of the speakers who agreed to come here, speakers who gave feedback that will help make this seem 10,000 times better. You know, always remember to share your dreams, because if you don't, they die. Thank you.
The next award I'll talk about is the Astronomical League Award. The Astronomical League Award is presented to any person, either amateur or professional, who has made worthwhile contributions to the science of astronomy on a national or international level. Previous winners have made contributions to the field of astronomy, founded other astronomical organizations, or made great contributions of their time and energy to the Astronomical League. Current officers of the League, until they're out of office for 1 year, or current members of the award committee, are not eligible for the award. The award committee consists of the current president, the immediate past president, and the second past president, all of whom must vote on the award. The selection of the award recipient must be unanimous. Nomination must be made in writing to the executive secretary and contain the affiliation with the league, if any, and the reasons the person should be considered for the award. It must be received at least 4 months before, and I won't go into all that. We were honored to present earlier in the week on Friday the award to Dr. David Levy, with the award for his lifetime dedication to amateur astronomy and the Astronomical League. And he had to leave early to catch a plane tonight, or he would have been here. Ron Kramer is the immediate past president, and he was one of 2 members. John Goss, who most of you in the room probably know or have heard of, is the 3rd member of that committee. So I think we surprised David. He didn't seem to be expected to do Ron did. So that's the kind of presentation we like to do, when we can keep it a secret as long as we can. So, David was really shocked and surprised, but we like to give out those kind of things. So let's give David a hand. If he's The next award, and this is the highest award we have in the Astronomical League, is the Leslie C. L. Tier Award, also sponsored by Explore Scientific. Thank you, Scott. The heart of amateur astronomy is observing. We can read all we want to about astronomical phenomena, but the real joy in astronomy is going out in the night sky and observing the objects about which we have read. Well, while most of us are casual observers of the sky, looking over the same few objects over and over. A few amateur astronomers develop their observing skills to the ultimate degree. They then use these skills to make careful observations of the sky and record them for scientific analysis. Whether the observation is done with a photometer, CCD, spectroscope, or just the human eye, the ability to find an object and record scientifically useful information is not a common trait. To recognize the amateur astronomer who is not only able to do this, but has contributed their observations to an ongoing observing program, the Astronomical League presents the Leslie C. Peltier Award. It was created in 1980, and the first one was awarded in 1981. It is with great pleasure that we wish to announce Julius L. Benton, Jr. as the recipient of the 2023 Leslie C. Peltier Award. And there's quite a bit here, but I'm going to read it because it's good stuff. Julius L. Benton Jr. has been an amateur astronomer nearly all his life, with extensive observational experience in many levels, and practices in the realm of solar system astronomy. Julius' interest in amateur astronomy began in childhood with the encouragement of his parents, Julius Sr. and his mother, Susan, as well as his aunt, Mary Ann Jones. It all began for Julius with a Christmas present of a small telescope, a 2.4-inch unitron refractor at the age of 10. You want to remember that? Okay. Julius extensively explored the heavens with that telescope, graduating progressively to larger telescopes. Seems to always happen, doesn't it? That aperture fever. And became fascinated with the always changing planets and the transient features they portrayed. It wasn't long that young Julius began documenting his observations by making careful drawings and observational notes into logbooks for future reference. Disappointingly, with the job prospects in professional astronomy, channeled Julius's academic talents toward an undergraduate degree in physics and environmental sciences. But his interest in solar system astronomy only increased with time. Julius attended his first amateur astronomical convention in 1970, where he met his future mentor, Walter H. Haas, and that's a name well known to several people in this room, founder and then director of the Association of Lunar and Planetary Observers, commonly called ALCON. The informal collegiality and diversity of these experienced observers in the ALCON inspired Julius to get involved in the organization as a paid member and observer. As his graduate studies concluded, Julius was asked to apply his skills and expertise as a knowledgeable amateur in managing ALCON observing sections. He was first appointed by Walter Haas to lead the ALCON Saturn section as its recorder. Recorders are now referred to as coordinators in May of 1971. Later on, Julius became a recorder of the Venus section in 1973. Julius has been profiled in his apparition reports concerning Saturn and Venus in the Journal of ALCON during the past 50 plus years, as well as producing a variety of materials freely available on the ALCON website. In later years, Julius also assumed responsibility for managing the ALCON Lunar Selected Areas program, that's a mouthful, as well. Julius' great interest and love for the solar system astronomy and the ALCON has also translated into added responsibilities, serving on the ALCON Board of Directors since 1994, and also supporting the organization as its executive director at various times since then. Well, Julius is an outstandingly skilled observer and a recipient of the Walter H. Haas Observers Award in 2018, Julius credits the success of the observing sections and programs in the legions to the legions of observers that have contributed observation to ALPO over the many years. Though through Julius's tutelage, many observers have been inspired and benefited from his encouragement, insights, expertise, and diligent interest in their efforts. In turn, Julius has been a champion of amateur observation of the solar system for scientific pursuit, and has promoted a shared long-time interest in these observers and their observations with the professional community. Julius' accumulative knowledge and experiences with the planet Saturn culminated in the publication of a popular guide to the planet entitled Saturn and How to Observe It, published by Springer. Through his many contributing services to the ALPO organization and the broader astronomical community, and his hard work in both observing the solar system and leading others to do the same, Julius Benton has broadened the popularity and increased the knowledge of lunar and planetary astronomy for many. Respectfully committed, the Leslie C. Galtier Award Committee, Roger S. Coleman, PhD Chair, Barry Meeman, who's the former president of the Astronomical League, and Russ Maxwell. So Julius is unable to attend to get his award in person. He is recording a video that we will post on the website and other social media.
Carol, you might want to mention that Walter Haas was the founder of ALCON.
Thank you. Ron just reminded me that Walter Haas was the founder of ALPO, so he's a significant player in that organization. Okay. And I think we were, I want to talk about the President's Awards that were issued this year, none of whom are here to accept it, but they will be setting up the appropriate ceremonies in their own areas. The first one is for our Astronomy Day coordinator, Gary Tomlinson. How many have heard the word Gary Tomlinson before? One or two? I got a call from Gary about 3 months ago, I guess. And he says, I sure hope I can hang on until June. He says, I'd really like to get my 40 years as Astronomy Day coordinator in the books. And he made so that's quite a feat for anyone, but 40 years he's handled that program. And there's been numerous awards presented during that particular time. At that time, when he gave us his intent to step down, we posted some requests for suitable candidates, and we came up with a great candidate. His name is Mike Morrison from the Omaha Astronomical Society. And I was talking to our Sky and Telescope representative just this afternoon, and she was telling me all the things he's already got in line, a new website, and he's really enthusiastic about going and running with it. In addition to Sky and Telescope, one of the three sponsors, including the Astronomical League, is AAS, which we're having a meeting within the next 2 weeks, and with the Astronomy Day coming on in the next month or month and a half, the fall version, we hope to have several entries for that program. We're going to be hitting social media and other sources very hard to get the word out. Because in a previous meeting this week here, I asked for a show of hands, how many clubs were involved in Astronomy Day? Several hands went up. But when I asked, do you know anything about the programs offered by the league? Maybe 2 people. So obviously we have a communication problem. So we're gonna hopefully fix that. The next President's Award I gave this year was to Don Knapp, one of our regional chairs. And he was very instrumental in 2021 when we had the virtual convention because of COVID. He was very instrumental in helping that website and many other things, assistant with the Astronomical League. Another special award, the President's Award this year, is for the Naperville Astronomical Association. On August 17th, a little less than a month from now, they will be celebrating their 50th year as an organization. And Alan, where's Alan? Yeah, there he is. He's our regional chair has agreed to make the presentation to them since I'm unable to be there. So thank you, Alan. Another name that may sound familiar in this room is Marilyn Unruh. Does anyone remember who that was? Yes. Few. For years, she handled the book service for the Astronomical League and did an excellent job of it. When people would request a very rare book, an astronomy book, she would always come through with it. It seemed like she always could figure out how to do it. She owned a bookstore in Prescott, am I right, Vinny? Yeah, Prescott, Arizona. And so she could really make things happen. A year ago, maybe 2 years ago, we discontinued that service per her request. With Amazon and other players getting in the field, she says, I will continue to help anyone who wants to find a rare astronomy book, but I think we better step down as far as having a formal program in place. So that's what we did. But we didn't recognize her at the time, and it's past due that we did. So the final award this year goes to Marilyn Unruh. She still lives in Arizona, Prescott, and we'll be sending the plaque to her. And now is the fun part of the evening. It's when we get to recognize people who get out under the stars and observe, not just casual observing. They've been through a ton of programs in order to get to the master observers level. We have 3 this year. Lauren Roger from Escambia Amateur Astronomers Association. Lauren, would you please come forward? The second person is Fred Yassert from the Kansas Astronomical Observers and Vice Chair of the Mid-States Region of the Astronomical League. Our final winner that we're going to present tonight is one to Bernie. Let me make sure I get this right. Bernie Vaness. I'm pretty close. Okay, good. He's a life member and member of the Hamilton Center of the RASC in Canada. And as far as we know, he's the only Canadian in the ranks of master observers. Well done.
I was just mentioning to Carol there, thank you very much, by the way. Thank you for the opportunity to observe with purpose. I find that a very important thing to do. I was mentioning to Carol that I'm also the chairman of the Hamilton Amateur Astronomers and the award director and the shoe shine guy and the picker-upper and all of that nice stuff. We've been trying for a number of years to get things to happen between the HAA and the Astronomical League. And you run around in circles as all international things happen, right? We all know that. But we're making strides toward it, and I hope that we can start moving towards including some Canadian organizations or clubs with the AL. And turn it
Now it's time for some more raffles and a couple of big prizes. Come on down, Scott. Thank you, thank you, thank you. Of course.
Okay, this is finally the end of the raffle fun and games. We've got each prize comes with a coffee cup. So the first one we're going to do is a wonderful little Astronomical League bucket hat. Everybody has their number on the back of the ticket they got earlier this evening when they came in. So 326 should still be here. We'll give you a nice, lovely hat and. Congratulations to you. Secondly, we've got a lovely duffel bag cup combination for lucky number 359. So, hey! Congratulations. The next one that was given to us is courtesy of James Dyer. He told us that it was from Celestron. So perhaps another gift is some Eclipse binoculars, some nice little, what was that, 10 by 52 roof prism binoculars for number 319. Check your numbers. We know we've gotten the number 319 here unless they ducked out. Shall we re-roll? Let's re-roll. How about number 332? Hey, John! Hey! And for our last one, we would ask Scott Roberts to come up and do the honors and actually pull the roll for this lovely eyepiece, this 90-degree eyepiece that he is presented for offer at the raffle tonight. If you would roll the dice for us.
So how do I do this?
Just press generate and it will give us a number.
Okay, you guys ready?
Big money, big money, big money.
All right, this is a 92-degree, 17-millimeter eyepiece worth $750. Wow. There you go. Wow. Okay. So this starts with a 3. And then there's another 3. 8. 338.
Oh no. They
with the buzzer. Okay, one more time.
One more roll. That's wow. This is whoever is missing the 3.
I know I'm on pins and needles here. Here we go. Okay, the last two numbers are 6 and 4. 364. Nice guy network. Here we go. Great. Thank you. Thanks, everybody. And that is finally the last thing that I
Thank you, Scott. Just very briefly, I know we're approaching the 10 o'clock hour. I'm not going to hold you very much longer. Just wanted to announce the I think I've got the wrong. Is that?
Is it on the other side?
I've got it. Here we go. Got it. Sorry. Each year, we present winners for the Library Telescope. We have 10 regions in the Astronomical League, and one out of each region is eligible to, one of the clubs is eligible to apply for it. In addition, we present one member at large for the Library Telescope. What they do is go back to their communities, or before I should say, make arrangements with a specific library to provide that telescope and do some of the maintenance involved with it. For the GLRAL, the winner is the Evansville Astronomical Society. For Merrill, MERAL, that's the Black Bay Amateur Astronomers. Good kid over closer, Jeff.
Sorry, that's my writing.
Yeah, no, they're fine. Back Bay Amateur Astronomers. For the MSRAL, this is another name that we mentioned before, Kansas Astronomical Observers. NCRAL is the Popular Astronomy Club. That club is always there doing good stuff, so nice to see that name again. For the NERAL, the Amateur Observer Society of New York. For NWRAL, the Island County Astronomical Society. For WRAL, the Astronomers of Humboldt. And finally, the member at large is Steve Boyner. Congratulations all. And we're going to get out here in about 5 minutes. Oh, Kathy, you've got it now, so come up.
Okay, somewhere back in the midst of time, someone prepared a brass logo of the Astronomical League. I don't know when, I don't know what the purpose was, but it looks really cool. And somehow I got a hold of the thing. I think someone gave it to me, and the purpose they thought was maybe to make a license plate, or maybe to make something, and so I've had it a long time. A friend of ours put the brass thing in a walnut plaque. Okay, it looks pretty good. It makes a great paperweight, but you know, I think it needs to go back to the league. So, Carol, here, you get it now. It's all yours. Thank you. you for all you've done, man. You're a good friend.
Thank you so much, Kathy. Another thing to take to the national office, sometimes they tell us not to bring in too much more stuff. Seriously, we follow your stuff as long as we get to catalog one of these days. Thanks. The final thing I'll talk about is ALCON 2024. Turn the page on this one, so to speak. After a wonderful convention, let's give the club another round of applause. Some of you were planning on being in Toronto, Canada next year for this event. We had some things that didn't quite work out, so we need to go to an alternate plan. And I was coerced by certain members of the executive committee a few weeks ago, asking if maybe a club in the middle part of the country might be available. So I took it back to the board of directors of the Astronomical Society of Kansas City, and it says, well, we're involved in a major fundraising right now. We don't know whether we have the time. But then they started thinking, and that, yeah, that might be a good thing to do. We have not, in Kansas City, there's not been a national convention since 2004. Had some regionals, but no nationals since that time. And they decided we were probably due to do another one. So anyway, it'll be in the month of July of 2024. If it works out as we think it's going to work out, one of the main features will be at the Linda Hall Technical Library. As you may or may not know, our Astronomical League winner this year has his observing logs on permanent loan to the Linda Hall Library. He also has his first telescope, Dr. David Levy, and I was talking to David today just before he left, and he says, I'm game to come, and he's already got his talk title for next year. He's just so enthusiastic for that. So another feature that will change slightly for next year is we plan to stream the convention next year. One of the things that we heard in 2021 when we had the virtual event was that many people could hear, particularly our older members, they could hear what we were doing online as opposed to these live events. And nothing wrong with live events. I like to come to live events, but some of the problems of hearing speakers when they're live. So we have made the decision to, if we can pull this off at all, is to have live streaming for next year in addition to the in-person situation, a hybrid situation, and have a nominal registration fee for that. As attendance begins to go down a little bit for these live meetings, it behoves us to look for alternate ways of letting more people participate in the event. And I think that's going to pay dividends for the next few years. After 2024, we will be going to Bryce Canyon. Thank you, Terry and Lowell, for setting up Chuck. How many of you were in Bryce Canyon a few years ago? You're actual observing outcome. And we'll be giving information very soon about the 2026 convention. We haven't made a definite decision, but we will let you know when that happens. I know it's getting late. Any questions? Short questions? Yes?
Do you have a date for Kansas City?
We will know within the next 2 weeks, I would say. It will be in July. Dan?
Yeah, just real quick, I really appreciate how youth was emphasized this year, and if anyone wants it, if they know say maybe a middle schooler or early high schooler, there's a real great resource. It's called the YMCA Camp Everhart at Quarry Lake, Michigan, and they have the usual horseback riding and archery, but they also have astronomy program. It's a nice dark site, and I happen to know the camp counselor, known for 35 years. His name is Darren Drake. Real expert on handling kids. He's also a teacher in Hinsdale and the Proviso Math and Science Academy near Chicago. So he's really expert at doing this.
So-
Besides that, Corey Lake is a wonderful scenic place to go to. Just beautiful.
Thanks for the information. That's in Michigan, right? I'll take one more short question and then, okay, thanks so much for joining us. And we'll see you next year. And thanks so much. Yeah, I thought they were very interesting.
I love going. Yeah.